relation. Now, take the reference of this diagram or this diagram, anyone, right? Now you can take this, right? If you have given any number, figure number 1, 2, 3, whatever it is, right? Any diagram you can give reference with respect to that figure, you write. Suppose if I am taking this as 1 and 2, or if it is figure 2, the same thing, this and this. You give figure number and then write with respect to figure mentioned here. So now, suppose I am taking this, right? This I am assuming body 1 and body 2. Same diagram I am doing. So taking 1 and 2 are as black bodies, both 1 and 2 as arbitrarily I am assuming the black bodies. Right? Now, what is the energy, right, emitted out of this body 1? Energy emitted from body 1 is EB1, right? This is per unit area, right? MCU power definition is, see, the rate of energy per unit area. See, suppose A1, capital A1 is the surface area of the body or surface 1. Then the total MCU power is EB1 into A1, right? Now this is the energy that is leaving this surface. Out of this, what is striking this? How much is actually falling on this? You have to multiply this with. This is the energy that is leaving the surface, and then out of this, what is falling on this is this. See, please remember, there we took the case of 10 units now. This EB1 into A1 is 10 units into what is F1 to 2? 0.2. So is equal to 2. So 2 units is striking on this. That is what we are writing in mathematics. This is, we have taken the example of some numerical values, but this is how it is. So EB1 into A1 into F12 is the radiation that is leaving the surface 1 and striking the surface 2. Let us assume this as Q1. I am assuming this as Q1. Similarly, tell me what is the energy that is leaving the surface 2 that strikes surface 1? Give us. What is that? Let us say I am writing this as Q2. Chepan. EB2, A2, F2 to 1. Now, they are exchanging energy between the two. See, after some time, both will come to the same temperature. That's what it is, right? So, energy or the heat transfer occurs between the two bodies or two surfaces or two parts, right, continuously, and at certain point of time, their temperature gets neutralized. Both will reach the same level. At that point, will there be any exchange of energy between them? No. Actually, as long as the temperature is different, like T1 is not equal to T2, this process of energy exchange between the two continues. But once, right, temperatures become equal, then there is no energy transfer. Now, let us say Q net, that is the net exchange of energy between these two is, or we can write this as Q net or Q1 to 2. Likewise also you can write, or simply Q1 to, right? That is the net radiation energy exchange between 1 and 2 is equal to Q1 minus Q2, right? Isn't it? So this is exchanging energy and this is also. So therefore, if you take at any given point of time, suppose if you take this body, it is receiving the energy as well as it is sending the energy. So what is the net exchange means? The difference between the two. So therefore, this is equal to EB1 into A1 into F12 minus EB2 A2 F2. Now, after reaching thermal equilibrium condition, after reaching thermal equilibrium condition, what does it mean? Temperature of the both bodies become equal. So in that condition, what happens to Q net? The net energy exchange is 0. So in that case, what can you write this as? EB1 A1 F12 is equal to EB2 A2 F2. But by definition, what is EB for us? Sigma T power 4. What is EB1? Sigma T1 power 4. What is EB2? Sigma T2 power 4. So when T1 is equal to T2, what happens to EB1 and EB2? They become equal. So therefore, in the next case, since T1 is equal to T2, right? EB1 is equal to EB2. Therefore, right, this stands cancelled out. Right? EB1 stands cancelled out on both sides. We will get A1 F12 is equal to sorry, EB2 A2 F21 F21. So now, what we have done is, when because of this, these two will stand cancelled. Now, this is known as reciprocity relation or reciprocity theorem.